Hello everyone. I hope you had a great first day of your senior year. I hope you have a lot of great days in your senior year. And I want to welcome you to the very first lesson of my flipped classroom. I hope you enjoy this method of learning. I know I put in a lot of energy to try and make things work easy for you so you can listen to them and go through the notes. So just help me help you by listening to and watching the videos. That will really help you. So we're going to start in chapter 1. We're going to talk about the real number system. And we're going to talk today, we're going to review reducing fractions. Now I know a lot of you don't like fractions, but I can help you make fractions easier and you can learn it, so just keep a positive attitude. I'm going to split lesson 1.1 up into several days. All right, I think there's 3 in total, and because there's lots to review about fractions, and I really want you to get a good handle on fractions. Our objective for the first day is I will review the definition of a factor and write fractions in lowest terms. So before we get started, you'll see this a lot. I'll be setting my pen. I'm going to pick light blue for my highlighter, and for my pen I'm going to pick purple. I think that'll work, hopefully. All right, here we go. Before we start, we've got to define a lot of key terms. Product. Product is a word that we use to describe the answer to a multiplication problem. When two things are being multiplied together, the answer is called the product. So anytime you see the word product, you know that you have to multiply, especially in an application. The product of 3 and 5 is, then you know that you have to multiply 3 and 5. All right? The next word that we have to define, here was product. Here's product. We have to define factor. Okay? A factor is one of the things that is being multiplied together. You can multiply lots of things together. More than 2 things can be multiplied together, and each one of those things is called a factor. So its formal definition is, it is one of the numbers or expressions, because we could have variables, that is being multiplied to reach a certain product. So if you look at these 3 examples down here, okay, the factors are the items being multiplied together. In each case, it's 6 times 3. I have these 3 examples here because I want you to see different ways that multiplication could be implied. We could use a dot, we could use an arrow, and we could use parentheses. All right? Now, the next thing that you want to notice here, the products, I have them all. Products are the answer to the multiplication. Okay? Product is the answer. Factors are the things being multiplied together. When something is factored, it is written like a number. If a number is factored, it is written in terms of 2 things being multiplied together. It's written as the product of 2 or more factors. 18 can be factored into some different factors. We can have 6 times 3. We can have 1 times 18. We can have 9 times 2. Additionally, we could have 2 times 3 times 3. The highlighted expressions are factors of 2. The one I just wrote has 3 factors, right? You can have 4 factors, you can have 5 factors, you can have a lot of different factors, okay? It doesn't just have to be 2. When you have a prime number, then prime numbers, there are only 2 factors for a prime number. There are only 2 factors for a prime number. They are 1 and that number itself. So 2 can be factored only into 1 times 2. 5 can be factored only into 1 times 5. 17 is factored only into 1 times 17. 29, 1 times 29. A composite number, when you hear the word composite, you know that it has more than just 2 factors of 1 and itself. There are other numbers that can be multiplied together to give you that product. Examples of composite numbers are 4, 6, I'm getting my highlighter here real quick, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21. Now notice that a lot of the prime numbers are odd, but not every one of them. And there are some prime numbers, there are some missing odd numbers. So just because you have an odd number doesn't necessarily mean that it's prime. It could be composite, as in 15, right? So notice with composite numbers, 4 can be written as 1 times 4 or 2 times 2, right? 10 can be written as 1 times 10 or 2 times 5. 18 can be written as 1 times 18, 2 times 9, or 3 times 6, and so on and so on. All right? So composite numbers have more than just 2 factors. Prime numbers only have 2 factors, 1 and that number itself. It is a good idea for you to memorize the first dozen or so prime factors. Just put them on a flashcard, write them on your mirror, and just start memorizing them because it'll come in handy for higher math. Okay? All right. I don't know whether you noticed, I'm going to flash back to the next screen, but I don't know if you noticed, but look at what is conspicuously missing between both of these categories. 1 is not included in either of these 2 categories, nor is 0. Okay? Those are special numbers. They are not considered prime or composite. So if you're asked to classify 0 and 1, you want to classify them as neither. Neither. They are not prime, nor are they composite. That's important to remember. That's why I got a big star for you on that one. Big, remember this. Right. When you want to factor a number into the product of its prime factors, you need to remember your divisibility rules. So look at the number and notice things about the number. Is it even? Well, if it is, then start dividing by 2. Not 4, because 4 is not prime. Start dividing by 2. Okay? If the digits of the number add to a multiple of 3, divide by 3. So what this means is that, say we have 243. 2 plus 4 is 6, plus 3 is 9. 9 is a multiple of 3, so 243 is divisible by 3. That's what that rule means. This one is my easiest one to remember. If the number ends in 0 or 5, divide by 5. Now, if you start going through this and you realize that 2 isn't working, 3 isn't working, 5 isn't working, then keep dividing by the other primes, like 77. You know, 2 isn't going to go into it, 3 isn't going to go into it, 5 isn't going to go into it, but 7 will. 7 and 11 make 77. All right? So when you multiply primes together, you have to just start dividing through by primes in order to figure out what that prime factoring is. You want to make sure that you continue to factor until every factor is prime. And then it's helpful, not always necessary, but I like to start by using my smallest number first. Like if it's even, I'll start using a 2, dividing by 2 first. Because then I get a nice pattern and it's easy for me to keep track of all my factors. Determine if the following are prime, composite, or neither. I'm going to switch to my pen here. If it's composite, then they want you to factor it into its prime numbers. All right? So let's start with number 1, 35. Is 35 prime or composite? Well, it has the factor of 1 and 35 and 5 and 7. So this is composite. And its prime factorization is 5 times 7. 22. Are there more than 1 and 22 as factors of 22? Well, yeah, because it's even, so you know that it's divisible by 2. So this is also a composite. And because it's even, I'm going to start dividing by 2. And I get 11. 2 is prime and 11 is prime. So the factors of 22 are 2 times 11. 28. It's even, so I know that there's at least, there's more than 2 factors for 28. I have 1 and 28, 2 and 14. 4 and 7, so I know it's a composite number. Now it's even, so I'm going to start dividing by 2. I get 2 and 14. 2 is prime, but 14 is not, so I'm going to divide by 2, and I get 7. So I get 2 times 2 times 7. That's the prime, that's 28 written as the product of its prime. Those are the prime factors of 28. 45. This ends in 5, so I know that I can divide by 5, and that gives me 9. This has to be a composite. And then 9 is 3 times 3. So the prime factoring of 45 is 3 times 3 times 5. 108, it's even, so I know that 2 is a factor. It's also divisible by 3 because 1 plus 0 plus 8 equals 9. So I know it has a multiple, 9 is a multiple of 3, so that means 108 is divisible by 3. So I'm going to start dividing by 3. If I divide that by 3, 108 divided by 3 is 36. 36 is divisible by 3. And I get 12. And 12 is divisible by 3. And I get 4. And 4 is divisible by 3. I get 2 and 2. So I'm going to have to sneak this up here and write it up here on the top. It is 3 times 3 times 3 times 2 times 2, and it's composite. All right, 19. Okay, is 19 even? Nope, so it's not divisible by 2. 1 plus 9 equals 10. So that 10 is even, and it's not a multiple of 3, so it's not divisible by 3. It doesn't end in a 0 or a 5, so it's not divisible by 5. It isn't divisible by 7 or 11 or 13, so we can say that 19 is prime. 34, well, we know it's divisible by 2 because it's even, so I'm going to start there. 2, if I divide 34 by 2, I get 17. 17 is prime. I know that because I know my list. So I'm done with 2 times 17. That's the product of its primes, and it's a composite number. 59. All right. It's not even, so that can't divide by 2. 5 plus 9 is 14. 14 is not a multiple of 3, therefore 59 is not divisible by 3. It does not end in 0 or 5, so therefore it is not divisible by 5, not divisible by 7 or 11 or 13, so this one is prime. And then we have 1. 1 is neither, and 0 is neither. Don't forget 1 and 0 are neither prime nor composite. When we reduce, what we're talking about there, the definition of reducing is writing the fractions in lowest terms. We're writing an equivalent fraction. It has the same value, it just looks different. It looks different because all of the common factors have been canceled. And that leads us to the term of lowest terms. A fraction is in lowest terms when the numerator and denominator have no factors in common other than the number 1. The basic principle of fractions. If the numerator and the denominator are multiplied or divided by the same non-zero number, non-zero is the key word here, non-zero, then the value of the fraction is unchanged. Equivalent, that's talking about equivalent fractions. As long as we do the same thing to the top or the bottom, to the top and the bottom, do the exact same thing, the fraction looks different but has the exact same value. Has the same value. Super, super important, okay? Because we're going to use this to reduce, okay? Reducing fractions, I'm going to show you 2 techniques. I always want you to try this method first because if this works, this is your easiest way of reducing your fraction. Regardless of where the smallest number sits, whether it sits on top in the numerator or on the bottom in the denominator, check to see if the smaller number goes evenly into the bigger number. If it does, then divide both the numerator and the denominator by the smaller number. So let's see what that means, all right? Number 1, I have 8 30-seconds, all right? Does 8 go evenly into 32? Yes, it does. So what I'm going to do is I'm going to divide the top and the bottom by 8. 8 divided by 8 is 1. 32 divided by 8 is 4. And I'm done. 21, example number 2, 21 over 63. Does 21 go evenly into 63? Well, yeah, it does. If I multiply 21 times 3, I'm going to get 63. So I'm going to divide top and bottom by 21. And I get 1 over 3. There's my final answer. All right, example 3, 14 over 7. Does 7 go evenly into 14? Yes, it does. So divide top and bottom by 7. 14 divided by 7 is 2, and 7 divided by 7 is 1. So that's the equivalent of anytime we have 1 in the denominator, that means we have a whole number, and it is, or an integer I should say, and that is 2. How about 50 over 5? I tell you what, why don't you hit pause on your player, try 4 and 5 on your own, and then come back and see if you got them right. Okay, welcome back. I'm going to do number 4 right now, and I'm going to, I asked myself, does 5 go evenly into 50? It sure does. So I'm going to divide top and bottom by 5. 50 divided by 5 is 10. 5 divided by 5 is 1. So I get a final answer of 10. Number 5, 3 over 21. Does 3 go evenly into 21? Yes, it does. So I'm going to divide top and bottom by the smaller number, and I get 1 over 7, and that's my final answer. Okay, we're going to keep going. What happens if the smaller number doesn't go evenly into the larger number? Well, here's another way that you can try and do this. You can write the numerator and the denominator each as a product of its prime. Then you're going to cancel common numbers that appear in both the top and the bottom. So if you have a 2 in the top and a 2 in the bottom, you can cancel that out. After you're done canceling, then you're going to multiply together any numbers that are left over in the numerator, multiply them together, and then you're going to multiply any numbers left over in the denominator and multiply them together. So let's take 12 sixteenths. Does 12 go evenly into 16? No. So now I'm going to prime factor 12. It's even, so I'm going to divide by 2, and I get 6. 6 is even. I'm going to divide by 2, and I'm done because 2 and 3 are both prime. So I'm going to rewrite 12. I'm going to go to my highlighter. I'm going to rewrite 12 as 2 times 2 times 3. Then I'm going to go over here and I'm going to do the same thing with 16. 16 is even, so I'm going to divide by 2, and I get 8. Then I'm going to divide by 2 again, and I get 4, and then I'm going to divide by 2 again. So for 16, I'm going to rewrite it as 2 times 2 times 2 times 2. Now, step 3 says that I'm going to cancel. Notice that I have a 2 in the numerator here and a 2 in the denominator here, so I can cancel. Again, I have a 2 in the numerator and a 2 in the denominator, so I'm going to cancel. Notice that I have to have it balanced between the top and the bottom. All right? I don't have any more 3's I don't have any 3's to cancel. I don't have any more 2's in the top to cancel out with the 2's in the bottom. So now I'm left to step 3, which is multiply the numbers left in the numerator together. Well, these become 1 when you cancel. So I have 1 times 1 times 3, which is just 3. Then in the denominator, both of these became 1. 1 times 1 times 2 times 2 is just 4. And my answer is 3/4. All right? Now, let's reduce the following fractions. 10 over 15. Well, 10 does not go evenly into 15. So I'm going to take 10 and I'm going to prime factor it, and it becomes 2 times 5. So this is 2 times 5. 15 is 5 times 3. Now I have a 5 in the numerator and a 5 in the denominator. So they cancel and become 1. Right? And I'm just left with 2 times 1, which is 2, over 1 times 3, which is 3. And my final answer is 2/3. Now, number 2. 25 over 45. Well, I'm going to prime factor 25. I'm going to divide by 5, and I get 5. So 25 is equivalent to 5 times 5. 45, I'm going to prime factor, and it becomes 5 times 9, and then 9 becomes 3 times 3. So this is 5 times 3 times 3. I have a 5 in the numerator and a 5 in the denominator, and I'm going to cancel. The only thing left I have in the numerator is a 5. I have nothing more that I can cancel in the denominator, and there are no 3's in the numerator. So now I just multiply what's left over in the top and what's left over in the bottom. The top is 5 times 1, which is 5. The bottom is 3 times 3, which is 9. Number 3, does 36 go evenly into 108? Okay, well it does. So I'm going to divide top and bottom by 36. If you didn't recognize that, you could prime factor each of them. 36 divided by 36 is 1, and 108 divided by 36 is 3. And there is my final answer. 27 over 51. Does 27 go evenly into 51? Well, 2 times 27 is 54, so no such luck. So now we're going to prime factor each of the numerator and the denominator. So 27 is 3 times 9, and then 9 is 3 times 3. So 27 becomes 3 times 3 times 3. 51, I'm going to divide by 3, and I get 51 divided by 3 is 17. Sorry, that took me so long. I just had a brain fart. I apologize. 3 is prime and 17 is prime, so that's as far as we can go over here. So this becomes 3 times 17. Now I have a 3 in the numerator and a 3 in the denominator, and I can cancel those out. I have nothing else that's common between the top and the bottom, so now I can multiply straight across, and I get 9 over 17, and there's my final answer. 132 over 77. Well, if I multiply 77 by 2, I get 154, so I know it doesn't go in evenly. But I'm going to use my bottom to help me figure out how to factor my top, all right? So I know 77 is the product of the two prime numbers, 7 and 11. Those double numbers, those are nice numbers. They're easily factored, all right? Now, I'm going to see if 7 goes into 132, and it does not. So now I'm going to try 11. I'm going to use long division. Okay, 11 goes into 13 once, with a remainder of 1. Bring down the bring down the 2, sorry, and then I get 2. So this is 11 times 12. Now I have an 11 in both top and bottom, and so I can easily write it as 12/7, just like this. Now I'm reducing the fraction 9 over 63, and I ask myself, does 9 go evenly into 63? Yes, it does, because I know my 9 times tables. And I'm going to divide top and bottom by 9, and you will get 1 over 7. Very good? All right, here's some other definitions that you're going to want to know. You're going to want to remember, you'll need this for your vocabulary packet, and you will need it because you need to know what books, textbooks, worksheets, standardized testing, what they're meaning when they use these terms. So a natural number are the counting numbers. It starts at 1 and goes up by whole numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We call it natural because that's how we naturally count things. Football, we count yards by 1 yard, 2 yards, 3 yards, 4 yards. That's a natural counting number. Fouls in basketball, we count as 1 foul, 2 fouls, 3 fouls, 4 fouls. All right? And money, we count money, $1 bills, 1, 2, 3, 4, 5. Okay? Whole numbers are every single one of those counting numbers. Let me write those counting numbers down here. So on. But you include 0 in the set of whole numbers. Okay? There's another one in here called integers. Integers are all the whole numbers and their opposites. All right? So the fraction or a rational number is an integer over an integer. 3 over 4. 10 over 21. 117 over 8. Those are all fractions or rational numbers. A proper fraction, when you see the term proper fraction, that is when your numerator is smaller than your denominator. 3/4 is a proper fraction. 10/21 is a proper fraction. An improper fraction is when the numerator is greater than the denominator. In the example up above under fractions, 117 over 8. The numerator is bigger than the denominator. And a mixed number. A mixed number is an improper fraction expressed as a whole number with a fraction piece. So we would take 8 and divide it into 117, and we would get 1, and that would be 37, and so that would be 4, that would be 32, so it would be 14 and 3/8. So you do long division. This is the number of whole 8s, groupings of 8 you can get out, and then you'd have one grouping of 3/8 left over. So it's a whole number and then the fraction. All right, so tomorrow in class we're going to be working on these problems that I've assigned, 1, 3, 5, 7 through 31. If there's anything you're not sure about with this video, please go back and look at it now. Come prepared to ask questions, and I will see you in class. I look forward to it. Thanks for listening. I appreciate it. Good night.